This meeting is being recorded.
In this next video from chapter 19 on electrochemistry, we're going to solve sample exercise 3 together. And in this exercise, we're asked to balance or write the balanced equation for the oxidation of phosphorus by nitric acid. So what that means is that they ask us to balance it. We can choose in acidic conditions. So that's what we're going to do here. So again, we're going to balance this in acidic conditions. Let's get started. So we've seen in the past videos that we always have to break this into a half reaction first. We're told that phosphorus will be oxidized. So let's see if we kind of discover that along the way. So I'm going to move a little quicker here through these steps since we've done this a couple times before. So here we go. We'll break apart into our two half reactions. So I separate based on the elements other than oxygen or hydrogen. So I have my phosphorus with my phosphorus, my nitrogen with my nitrogen. Then in my next step here, I want to balance everything but oxygen or hydrogen. So let's go ahead and do that. So balance oxygen first. So I have 4 oxygen here. I'm sorry. I meant I have 4 phosphorus here and only 1 over here. So I have to place a 4 in front. So we're balancing the phosphorus. The nitrogen is already balanced. So then we can move on to balancing the oxygen. So now we have 4 oxygen on this in this compound, but now that we have multiplied it by 4, we actually have 16. So we're going to end up adding 16 water to the side to add those 16 oxygen. Here we only need to add 2 additional water molecules because we only need 2 additional oxygens. Then we have to adjust for the hydrogen. So I have over here 32 hydrogen. Here I have 8. So I need to make up for the difference. So I need to add 24 hydrogen to this side, H plus. Then I need to add 4 over here to balance out this half reaction. All right, so let's rewrite things here. So now I have 16 H2O plus P4 gives me 4 H2PO4 negative and 24 H plus. All right, so our next step here, we're going to balance our charge. So we can set any uncharged or neutral compounds to 0. So both of this side is 0. We see plus 4 here, and well, that should be -1. So we go from plus 3 to a 0 here in our reduction half equation, and that's what we expect because we know that this is supposed to be the oxidation of phosphorus. Over here we go from 0 to -4 plus 24 or positive 20. So we need to account for these with electrons. So I'm going to add 20 electrons over here to balance out this difference in charge. And then over here, I'm going to add 3 electrons to the reactant side of my NO3 half reaction, my reduction half reaction. All right, now we can combine all of our, actually, first we need to make sure our electrons are equal. And we have 20 over here in this oxidation half reaction, and then we're adding 3 in our reduction half reaction. So I'm going to multiply everything over here times 3. And then we'll rewrite that equation below. And then I'm going to multiply everything over here times 20. So let's see, that will give me 48 H2O. And then that'll be plus 3 P4. And then my other side, I'm going to have now 4 times 20 or 80 H plus 20 NO3. All right, and I know that I would have 60 electrons over here now, but that would cancel with the 3 times 20 electrons that we're adding on the product side. So that's why I did not write them, because I know that they're going to cancel out. So on my product side, I have 3 times 4 of my hydrogen phosphate over here. So we have 12 H2PO4, and then my other product will be, what do I have? 24 times 3, so 72 H plus. Sorry about that. And then from my second half reaction, I'm going to add 20 times NO, and then 2 times 20 is 40 H2O. All right, so we're almost there. Now we can cancel any of our same reactants and products. So we can cancel out, for example, we'll end up with just 8 water on our reactant side now, because I have 40 that I can subtract from my product side. I still have my 3 phosphorus. My H plus can cancel with the H plus over here. So 80 minus the 72 from that side, I'm going to be left with 8 on my reactant side. I still have 20 NO3. Now let's move to our products. We see 12 H2PO4 negative plus 20 NO, and we've canceled out the water on the other side. So this ends up being our overall balanced chemical equation in acidic conditions.